Dr. Chip Fletcher is the Associate Dean for Academic Affairs and Professor of Geology and Geophysics at the School of Ocean and Earth Science and Technology here at UH Manoa. He did his undergraduate at Albion College in Michigan in geological sciences and English literature, and then received his master's and PhD at University of Delaware in coastal marine geology. Dr. Fletcher teaches graduate and undergraduate courses emphasizing earth science, climate change on Pacific Islands, and coastal geology, and he supervised dozens of graduate students. He's been awarded the University of Hawaii Chancellor Citation for meritorious teaching and has been recognized by the U.S. Environmental Protection Agency with an Environmental Achievement Award in climate change science. Dr. Fletcher's published well over 100 scientific papers and has recently published 3 books: Living on the Shores of Hawaii, Natural Hazards, the Environment, and Our Communities, Physical Geology, the Science of Earth, and Climate Change, What the Science Tells Us. What he's going to talk to us about today will change your world forever. And I will turn it over to Dr. Fletcher. Thank you so much for being here today.
Thank you, Cynthia. So I title this, The Next Few Years Will Be the Most Important in Human History. In fact, this decade, the decade of the 2020s, if we do not cut our global greenhouse gas emissions by very dramatic amounts, we are looking at a planet that is going to warm over 2 degrees C, probably over 4 degrees C. And we'll be stuck with having to figure out the technology to pull carbon out of the atmosphere as the way to regain a livable planet. So let's walk through this phenomenon of climate change. There we go. And it begins with the greenhouse effect. So the greenhouse effect works by sunlight arriving to Earth. It moves through Earth's atmosphere, and if it happens to hit a ground, it will largely be reflected back out to space. And not do any work on the climate. But if sunlight hits a darker surface, such as an ocean or a continent, it will warm it up, and that warm surface then will re-emit the energy at a different frequency called infrared energy. And we have some gases in the atmosphere which tend to trap infrared energy. These are the greenhouse gases. And if we did not have some natural greenhouse gases, the average temperature of the planet would be below freezing. So we're happy for the greenhouse effect. The problem is that we are enhancing it through the burning of fossil fuels and through destructive land use practices and releasing more of these greenhouse gases to the atmosphere. Once you get some additional heating to the atmosphere, it will hold more moisture. You all know that when it's hotter outside, it also tends to be more humid. And it turns out that the most powerful greenhouse gas is actually water vapor. But you learned in 8th grade that the water cycle operates on a 10-day to 2-week cycle. And so the only way to increase the amount of that greenhouse gas, being water vapor, is to heat the air with something else, and that would be the carbon dioxide or nitrous oxide or methane that we release. So this is called an amplifying feedback. For instance, if we warm the atmosphere 1 degree Celsius with anthropogenic release of greenhouse gases, we will get an additional 1 degree of Celsius of warming through this amplifying feedback process. This is one of many feedback processes that characterize the climate system. Many of the others are cryptic, they are difficult to understand, and so there's a great deal of uncertainty as we move into a warmer future, how other types of feedback processes may kick in and result in some potentially very negative impacts. So we measure the rise of carbon dioxide, which is the primary greenhouse gas that we track because it has a very long residence time in the atmosphere over centuries. And we actually define global warming potential in terms of equivalent carbon dioxide. And so beginning in the late 19th century, when we discovered oil and humanity's population began to rapidly expand, the amount of carbon dioxide in the atmosphere has increased almost 50%. We've gone from a natural background level of what should be about 280 parts per million. Now, this month, we hit 416 parts per million. And because carbon dioxide traps heat that would otherwise escape to space, we see an increase in the temperature of the atmosphere at Earth's surface, where we live and where natural processes and ecosystems operate. You can see that this temperature history is variable. Typically, the warm years are El Nino, whether it's a strong or weak El Nino years, and the cooler years tend to be either volcanic eruptions, which put aerosols into the atmosphere and reflect sunlight, resulting in cooling, or La Nina years, which tend to take heat out of the air and bury it in the West Pacific warm pool. So the amount of CO2 we are releasing into the atmosphere is accelerating. The warming is accelerating. We're currently at 1.2 degrees Celsius, or about a little over 2.1 degrees Fahrenheit of warming above the background level. We are on track to reach 1.5 degrees Celsius in a decade, and by 2045, we're on track to reach warming of about 2 degrees Celsius. Between 1990 and 1980, there was a new temperature record set every 13.5 years, but since 1980, a new temperature record has been set every 3 years. So this is evidence of that acceleration. This is the warming displayed in the form of surface temperatures from both the ocean and the land collected by NASA. You can see the variability of the warming from place to place and year to year, but right about now, as we enter the 1980s, the warming really starts to accelerate. And we have this very dramatic warming taking place in the Arctic called Arctic amplification. Because the Arctic is looking more and more like the tropics, it has destabilized the jet stream, and the jet stream is developing very large meanders, which bring Arctic air down into latitudes where we're not used to seeing it, and that leads to billion-dollar crop losses. And meanders will pull tropical air way up to the north, also leading to extreme weather events like drought and a feedback effect of wildfire. That big blue spot in the North Atlantic is the coldest that it has been since Ben Franklin first began measuring it as he sailed back and forth between the colonies and England. And it is produced by cold, fresh water running off of the Greenland ice sheet as it melts because of the warming air. So we emit these greenhouse gases, carbon dioxide, and about 86% of the gases that are emitted are coming from our industrial activities, largely burning fossil fuels, and about 14% is coming from land use practices like deforestation and inappropriate agriculture, which release carbon dioxide into the atmosphere. The atmosphere holds about 44% of the CO2 that we release. About 29% is taken up by the process of photosynthesis, and through that also storage in soil. And about 23% is dissolved in the ocean. Emissions tend to follow world GDP. And you can see since 1950 or so, the end of World War II, there is roughly a linear relationship between atmospheric carbon dioxide on the vertical axis and world GDP in terms of trillions of 2005 dollars on the horizontal axis. And that line has a slope of 1.7 parts per million by volume of carbon dioxide per trillion dollars of world economy in 2005 US dollars. We need to break this relationship. We need to continue to have a healthy economy and not have it dependent on the release of these dangerous pollutants, these greenhouse gases. So with only 1.2 degrees Celsius of warming so far, we have already documented a whole litany of negative effects. This is maybe 10% of a list that I could show you. We now have sea level rise, which scientists have been polled, and a structured survey concluded that the scientific community believes there's a 10% probability of 2 meters of sea level rise this century. Antarctica is melting 3 times faster than last decade. Greenland is melting 4 times faster than last decade. And this past summer lost 600 gigatons of ice. That amount is what in a typical year, Antarctica, Greenland, and all the world's mountain glaciers combined will lose. And we lost just that amount from Greenland. A previous average for losing mass on Greenland is 281 gigatons per year. Greenland and Antarctica do have tipping points where they are warm to the point where we cannot stop it. They will continue to melt on their own. Parts of West Antarctica ice sheet, we in fact have already pushed past their tipping point. The entire Antarctic ice sheet and Greenland ice sheet are believed to have tipping points someplace warmer than 1.5 degrees Celsius, which we are on track to hit in a decade. Arctic sea ice volume is basically a collapsed system at this point. It's down 50 to 70% since we put our first satellites up. There's been a 12% increase around the world in extreme rainfall and 10% increase in drought. Weather-related natural disasters have more than tripled since the 1960s. And annually, these disasters cause more than 60,000 deaths. 2/3 of humans on this planet face a water shortage for at least 1 month every year. There's been a decrease in the vertical circulation of the ocean, which is significant because that's how we take heat out of the atmosphere and store it in the deep sea. And so as that decreases, one of our natural limits on warming is being removed. And the oceanic gyres, the 5 large gyres of the 5 major ocean basins, are moving, and they are shifting poleward away from the equator. The ocean is warming, its pH is dropping, and the dissolved oxygen content of the oceans is also decreasing. We've lost 2% dissolved oxygen since 1950. The global wildlife population is being clear-cut. It has decreased by 60% in the last 40 years. Marine and terrestrial extinctions are now described by scientists as Earth's 6th mass extinction event in the course of its 4.6 billion year history. And hurricanes are changing in ways that are more dangerous. Coral reefs are unlikely to last another 30 years. All right, so we are fundamentally changing the planet in ways that actually threaten our community, our socioeconomic framework. And the realization of this brought the world's nations together in one of the annual COPs. A COP is a conference of parties. The United Nations has been holding these for over 20 years. And in 2015, the Paris Agreement was signed at the annual conference on climate change. And it was agreed that all the nations would stop global warming before 2 degrees Celsius, and that they would pursue efforts to end warming before 1.5 degrees Celsius. Now, it's notable that although every nation agreed to nationally determined reductions in greenhouse gas emissions, none of it was, what's the word, absolutely committed to. They were all voluntary, in other words. And only a handful of nations are actually achieving their pledge. So here we have the history of carbon dioxide emissions. You can see beginning in 1850, the steep climb of these historical emissions. And we are now approaching 40 gigatons per year. That's billion tons of billion tons of CO2 per year. And if we want to stop warming at 1.5 degrees, that has to happen. This year, literally 2020, has to be the first of every subsequent year where our emissions are cut by 7.5%. Now, the COVID-19 pandemic is being projected to cut our greenhouse gas emissions globally, perhaps as much as 5%, someplace between 3 and 5%. And we are seeing major economic recession developing. We, here in Hawaii, for instance, just 3 months ago, 4 months ago, we had the lowest unemployment rate in the nation. We had 2% unemployment. We are now up to over 30% unemployment because of the shutdown of businesses, largely related somehow to tourism. Emissions must end by 2050, and we must remove CO2 from the air for the next several centuries. But we have developing nations in Africa, in Central America, South America, and also India and Southeast Asia. Those developing nations deserve modern hospitals and highways and food and water security systems. And the fastest and best way for them to build those is through using the infrastructure which is already in place, the fossil fuel infrastructure, from construction equipment to their electrical grid, which is driven by fossil fuels. And if we believe in global equity and improving societies, then the Western world that is already developed actually need to reach zero emissions by 2030, giving time and room for the developing world to achieve their lifestyle goals as we aid them and help them convert over from fossil fuels to renewable forms of energy. Unfortunately, fossil fuel use is accelerating faster than renewable fuel use. So this is the data from 1965 up to last year, 2019. You can see that there's faster growth in natural gas, coal, and oil than there is in all these other non-fossil fuel forms, such as bioenergy, hydro, nuclear, wind, and others. In fact, every global energy economist that I have found is projecting continued carbon dioxide emissions to mid-century. All those colored lines that you see are projecting continued increase in carbon dioxide emissions. The two lines that are heading down are the pathways we need to follow to stop at 1.5 degrees or the purple dotted line, is 2.0 degrees. So CO2 emissions continue to grow. In 2017, global emissions grew 1.5%. In 2018, they grew a little over 2%. Last year, the growth was less. It was about 0.6% growth in emissions. And as I've mentioned, that should say 2020. We're looking, this year, we're projecting between a decrease of 3 to 5%. But we need to get to 7.5% per year. And it's widely agreed that after the pandemic is over and we come out and turn our economy back on, that there will be a bounce back effect. And that bounce back effect we have seen take place after other recessions, such as the 2008-2009 recession. This is actually an opportunity for us to pivot our economy. Unfortunately, we do not have the leadership in Washington that is likely to take advantage of that opportunity. Hopefully here in Hawaii, we do, but getting away from, for instance, here in Hawaii, our economic one-trick pony, which is tourism, and diversifying and pivoting away from such a fragile economic framework, this is an opportunity. However, it's expected that you look at all the indicators, we're actually on track for over 3 degrees of warming before the end of the century. If you follow the United Nations climate modeling, where we have different scenarios for greenhouse gas emissions based on social and economic behaviors, we're basically tracking an increase of 6.0 watts per square meter of Earth's surface. It's not the worst case scenario, which is 8.5, but it's nowhere where we need to be to have a safe future. Agriculture is a special category. It's responsible for 31% of greenhouse gas emissions. And it points to the fact that the problems developing with our planet are not purely and solely related to climate change. There is, in fact, a mosaic of impacts that our expanding human population is responsible for. Pollution, including plastics, mining in a way that is not recovered or restored, where the landscape is not restored, habitat destruction for extractive resource use. There are a number of very negative behaviors that the human population has been engaging in. Several of them cluster together to produce climate change, but others not necessarily. Food is one of these that spans all of our human behaviors, and if we can repair some of our poor food behavior, we can go a long way towards not only helping to solve climate change, but also habitat destruction and other ills. Since 1970, food crop production has increased 300%, and half of all agricultural expansion has come at the expense of forests. The food supply chain is responsible for about 26% of greenhouse gas emissions, while another 5% comes from non-food agriculture, such as biofuels and textiles. 43% of all ice and desert-free land, in other words, usable land, and 2/3 of all fresh water is for food production. Unfortunately, we engage in a form of industrial agriculture which relies on synthetic pesticides and nutrients, which spill off of our fields into surrounding waterways and watersheds, and from there down into the coastal ocean. This inappropriate use of these synthetic chemicals is responsible for 78% of the coastal dead zones of the world, of which there are over 2,000. Also, deep plowing, which has become the standard for industrial agriculture, opens up soil to the air. You have oxidation of the carbon in the soil, which turns into both methane and carbon dioxide. You dry the soil and you expose it to runoff from precipitation, which leads to erosion. Soil is an extremely precious resource, and yet we don't treat it that way, and we need to. Producing beef generates 100 times more greenhouse gas emissions than plant-based food. Over 80% of all farmland is used for livestock, but it produces just 18% of food calories and 37% of protein. Cattle and the grain they use need 1/3 of all available land surface on this planet. 16% of all available fresh water. 1/3 of worldwide grain production goes to feed cows that we slaughter within the first 24 months of their lives. Otherwise, they would live to an average of 40 years of age. And we're deforesting the planet at the rate of 30 football fields per minute, largely to raise cattle and the grain to feed them. This habitat destruction brings animals and humans into contact and creates a form of disease known as zoonotic disease. And COVID-19 is the latest version of a zoonotic disease. Agriculture already occupies 43% of the world's land and uses 2/3 of the world's fresh water. Deforestation and habitat destruction is driving wild animals out of their normal locations, bringing them into closer contact with human communities. This leads to zoonotic disease, and you're familiar with many of these: the Ebola virus, HIV, dengue, malaria, West Nile virus, Zika virus, SARS, MERS, anthrax, Marburg virus, and COVID-19 is the latest. These are all given to humans through contact with animals. The germs that spread these include not only viruses, but bacteria, parasites, and fungi in rare cases. These germs may exist in perfectly healthy animals, but they can turn pathogenic when they spill over into humans. Additionally, they may evolve so that they not only experience animal to human infection, but they can become human to human infectious diseases. Three out of 4 new or emerging infectious diseases come from animals. 335 diseases have emerged in recent decades, and at least 75% of them come from animals. The zoonotic viruses from wild mammals largely come from rodents, bats, primates, deer, and wolves. They can be vector-borne, such as from ticks, mosquitoes, fleas, and snails. We can have direct contact with them from markets that sell meat or from contact with animal body fluids. They can be food-borne infectious diseases or waterborne. And where we raise animals in concentrated feeding operations, we have a special condition which leads to the growth in pathogenic viruses. There is a strong climate change connection. Warming expands the vector range. Floods and fires and other climate emergencies drive animals and humans together into contact. Drought and heat waves do the same thing. And concentrated animal farming operations promote evolution of these pathogens to become more virulent. So there in the background is a picture to double or triple by 2100 in order to keep pace with population growth and food demand. CAFO is a breeding ground for especially virulent pathogens. Normally, a virus will evolve a more moderate virulence to keep from killing their hosts. But when you have this close contact of multiple hosts, the dense packing leads to host-to-host transmission very readily, and there's less evolutionary pressure on the germ to reduce its virulence. In fact, there's a link between intensive poultry production and the emergence of what's known as highly pathogenic forms of avian flu. Europe and the US are also the world's biggest exporters of swine and exporters of swine flu. So how do we double or triple food production without unleashing a host of new infectious diseases? The rise of carbon dioxide in the atmosphere also impacts the nutrition of our food. We rely on wheat, soy, rice, and maize as the four fundamental cereals for human nutrition. These staples grown under higher CO2 have up to 30% less protein, zinc, vitamin B complex, and iron. Let's look at wheat as an example. The global wheat today provides 20% of all human protein, but the yield is threatened by drought, flood, and higher CO2 content. By mid-century, the demand for wheat is projected to increase by 60%. The actual yield is projected to decline by 15%. By mid-century, an additional 300 million people will be malnourished. As a result of this impact, and an additional 1.4 billion women and children are likely to have anemia or iron deficiency. We also have a global freshwater crisis. 1/4 of humanity today faces a looming water crisis. 17 nations are under extremely high water stress, meaning that they use almost all the water they have every year. And we're starting now to hear every summer from cities in the Northern Hemisphere that are on the verge or have completely run out of water. We heard about Johannesburg, South Africa, which came within 1 month of completely running out of water. And the Indian city of Chennai, 10 million people, a mega city, actually did run out of water this past summer. All 4 reservoirs dried up, and it led to a mass human exodus out of the city. Food and water shortages can lead to violent conflict, and the US military sees this problem as one of prime importance. In fact, we are now approaching 1% of all humanity who are displaced from their homes because of conflict that can trace back to a climate change cause. Well, it turns out the continents are already approaching 4 degrees C of warming in the summertime. And the coming summer of 2020 has been projected, in fact, to have a 75% probability of being the warmest year on record. Last year was the second warmest year on record. And with these extremely warm years, which are now occurring 1 year after another, we are seeing massive heat waves. Last summer, we had 2 heat waves hit the eastern states in the US. We've never had 2 before. And then in Europe, they saw 3 heat waves. That was also a record. These heat waves lead to food failure, and the probability of any 2 bread baskets of the world failing simultaneously is increasing dramatically. And we can afford to have a single bread basket fail, and the global food system will adapt. But if you get 2 failing simultaneously, this will rupture the food distribution system in ways that I am afraid of, because here in Hawaii, we live at the tail end of the food distribution system. This warming has led to 9 global scale biophysical systems which are now unstable. The great pine forests of the north, because of drought and wildfire, are shifting from being net carbon sinks to being carbon sources. Permafrost ecosystems are collapsing 70 years sooner than expected. The Atlantic vertical circulation, the overturning circulation, has slowed down about 15%. As I mentioned before, this leads to less heat being exported to the deep ocean. That means you get a buildup of heat in the Atlantic tropics that can lead to the growth of superstorms. You get the buildup of heat in the South Atlantic because it's not being exported to the North Atlantic by surface currents that are part of the vertical circulation. That heat in the South Atlantic leads to accelerated melting of the Antarctic ice sheet. There are also other effects from the slowdown in circulation. We see the Amazon and the Congo rainforests experiencing more drought. That's the surface circulation. And these are the feedback effects that result from that slowdown. The West Antarctic ice sheet appears to be in a state of collapse. Melting appears to be irreversible. This was the conclusion of a set of papers that came out in 2014, 6 years ago. And we're now fearing about some East Antarctic ice streams, which taken together have the potential to raise global sea level 2 to 3 meters. They appear to be close to passing a tipping point and going into irreversible melt as well. Greenland ice sheet could be doomed at 1.5 degrees C of warming. You notice the area in the center of the Greenland ice sheet, which is not red. That's the high altitude plateau. That continues to get more snow than melt every year. But the rest of the ice sheet, you can see in the increasingly hot colors, have more melting than snowfall. And overall, the Greenland ice sheet as an ice account is rapidly losing ice. It's in a negative state. If we increase the melting of that high plateau area, which we have done now for 2 or 3 days last summer, and we did for 1 day in the summertime 5 years ago, the more that increases, the more the elevation of that high plateau lowers, then you get an increase in the probability of more melting, which lowers it some more, which increases the probability of more melting. And that's the feedback effect that we don't want to breach. It would be pushed into a state of unstoppable melting. Coral reefs have been projected to be largely lost, 99% loss at 2 degrees C, which, as I mentioned earlier, we're on track to reach by shortly before mid-century. And the Amazon, we have lost or destroyed 17% of the Amazon. The estimates are that between 20 and 40% loss pushes the Amazon into a tipping point where it will just unravel. And Arctic sea ice, at 2 degrees global temperature warming, there's a 10 to 35% chance that we will start to see ice-free summers. So we're running out of time. The last little bit is that heat-trapping gases come from 6 sectors, 25% from electricity production, about the same from food, agriculture, and land use, 21% from industrial activity, 14% from transportation, about 6% from our buildings, and another 10% from other energy-related emissions. To cut back on the greenhouse gas production of electricity production, we need to shift over to renewables, and we have to enhance efficiency. That can give us major advantages. And with regard to food, ag, and land use, we currently waste as much as half of all the food we produce. Just think half of the greenhouse gas production could be cut if we stopped wasting food. We also need to shift our ag processes so that soil is preserved and the carbon in the soil acts as a sink instead of a source. And we need to protect ecosystems, stop expanding ag, just stop expanding ag, especially into natural carbon sinks. Industry needs to address the loss of refrigerants, which have incredibly powerful greenhouse gas warming potential. We need to cut down on the waste, and we need to improve materials that release carbon in their production, such as steel and cement and tin and other types of materials that release a lot of carbon in their production. Transportation system needs to electrify, and those electrons need to come from renewable energy. And we need to enhance the efficiency of transportation, and buildings need to enhance their efficiency and shift their sources of energy. We also need to stop destroying natural carbon sinks. We need to shift ag. We need to use degraded land and protect and restore ecosystems. And improving society, making the use of fossil fuels a moral violation, educating and enhancing the health care availability to the world's female population so that they are not in control, so that they are in control of their bodies and not the male-dominated cultures that exist in so many primitive locations. All of these can come together, and we can solve this problem. What can you do as an individual? Eat a more plant-based diet, talk about climate change, get a daily dose of climate news, vote to repair the climate, to protect ecosystems, and to build resilient communities that use sustainable practices, and join collective community action. And I will end with that. And if there's any time left over, I'll be happy to take any questions, and I can stay long as well. Thank you.